Another part of our sample program that needs to be stored in initialized data segment is this literal string, hello world. These characters have to be stored somewhere in the executable file, and this text is stored in initialized data segment. So right here, these characters, hello world, for them to be displayed by the program, they also are loaded with the executable program into this initialized data segment. We also have something called uninitialized data segment, and this data segment is used for variables such as int x, which is a global variable, but it does not have any kind of initialization. So when we define objects or variables in global scope and do not provide any kind of initialization to them, they will be initialized to 0 by the loader. So when this program right here is loaded into computer memory, its image corresponds to this part, and then any variables that are uninitialized do not exist in this image, but the space for them is calculated by the loader, and it's allocated in physical computer memory, and all this memory, completely entire memory block, is initialized to 0. So having this not set to any specific value is an equivalent to using initializer equals 0. Right, so when the variables are not initialized, they're set equal to 0 anyways. All the memory that is allocated to global variables which are not initialized in any way will be simply containing all zeros. There is also a stack memory segment. And this memory segment is located in the higher addresses area right here. And what it contains is a set of local variables of functions like main. For instance, if we change back this variable to be a local variable, which means that it's a variable declared inside function body right here, then this variable, and I will again provide some sort of initialization for it, this variable will not exist until the function is invoked. This opening brace right here will actually allocate enough space in the stack area to contain variables like x. If function main calls some other function, make a call into another function, and there's another function right here, this other function will actually construct its own space for its local variables. When function returns, its stack frame is deallocated, so it goes back to become available again. And when main function returns back to the operating system, its own stack frame is also deallocated. In other words, stack area is an area for temporary storage of local variables for as long as function needs the space to contain its local variables. So we call them local variables because they're sort of like local objects inside functions, inside these the scope between the opening brace and the closing brace. And as I told you, the life cycle of these local variables is limited only to the duration of this specific function execution. When this function returns and is no longer executing, the memory associated with this variable is returned back to the system. It's good to know that as the stick memory segment is used by our program as a result of calling functions such as main, we say that the stick grows in a direction of lower addresses. So it starts at the higher addresses in memory and keeps growing in the direction of lower memory addresses. And when function return, so they finish their execution and some functions will return back, the stack will collapse back to its original space.